So, quiz preview. Lots of things to get on our graph to help us figure out some of this information. We're going to be naming the center line, or if we have a vertical shift, we'll get into that in a minute, the amplitude, the period, and any phase shifts that there may be. So we're going to graph one period, and then labeling our ordered pairs, because that way we're not just having random points all over the place. So I look at this and I say, okay, the only thing basically I see, my amplitude is going to be 4. Now I know my A value is -4. I get that. But again, amplitude is an absolute value. It's like a distance. So we're just going to put that down as 4. Otherwise, there's nothing else really that's going on here. My period's not going to be different from anything out of the ordinary. Sine and cosine always have a period of 2 pi. So we remember because, well, we've gone over it and over it and over it. I mentioned it, over it. This guy, okay, base graphs. Got to have them drilled in by now. If not, well, you got one more day to drill them in. Because then everything bases off of that. So normally, we would just be going, since it's cosine, starting at 1 and working our way along. But we have an amplitude this time of -4. So instead of starting at 1 like I normally would, I'm going to start at -4. So I'm just going to multiply each of my y values by the amplitude. Normally here I'm at 0, I'm still going to be at 0. Pi, normally I'd be at 1. Excuse me, normally I'd be at -1. But when I multiply it by -4, I end up at +4. 3 pi over 2 is normally 0. Still be at 0 because 0 times 4 doesn't change anything. Not even -4. And then at 2 pi normally I'd be back to 1, but I'm multiplying by -4. So basically we took a typical cosine graph, flipped it over the x-axis because of the negative, and went about our business. Now, when it comes to the 5 ordered pairs, if you label them all on the axis like this, I don't mind if you don't put coordinate points for all of them like I did up on the board. But if you're going to just put like this and pi and 2 pi and I'm seeing random dots in places, that's when I want you really to specify where it's at. As long as I can tell, I can look at this easily and say that's pi 4, that's pi over 2, 0, that's 0, -4. I can tell really easy. But if you're going to go into sketch mode, then I need something like, pi 4 or 3 pi over 2, 0. So I'm very, very easy to tell where your points are at, is what I'll be looking for. So I guess for this first one, I will do it all, just so we don't have any issues here. No phase shifts. My center line, oh, I'm sorry, I'm on a roll.
Okay, I'm just kind of confused when you said that when you have like pi over 2, how it would regularly be, or normally be at 0. How do you know that?
Okay, because these are my typical like base or parent graphs for sine and cosine. So typically, if I'm making a cosine graph, my first value would be at 1, except this time I had an amplitude of -4. So what's going to happen is, for all of these, I'm going to be multiplying all of them by -4 when I go to plot them because of that amplitude. So like when I said at pi over 2, I knew I was at 0, because normally at pi over 2 I am, and multiplying it by any value isn't going to move it, because 0 times anything is going to be 0. So that's how I knew where those initial, if I'd have made my base graph first and then worked off of it, because that's what we do like when we're doing it like in my other Algebra 2 classes, we had always made those original base dots just to have something to kind of reference. And then we'd go back and we'd be like, okay, well it's 1, it's times -4, and make the other one. So sometimes that can help. Sometimes it makes things worse. I'm not sure, but this will always be where I base everything off of those base graphs. Uh-huh.
So when we put amplitude
Yes.
on this side, do we just leave it as an absolute value?
Yes, your amplitude itself will always come out as a positive value, even though your A value may be negative. Because the actual amplitude, and we'll talk about this as we do the center line. Remember, the center line is where is the middle of my graph vertically. In other words, if I look at the maximum up here at 4, and I look at the minimum down here at -4, what's in the middle? 0. And that's a baseline for me, because typically on all these graphs, 0 is going to be my center line. So you either, my center line would be y equals 0, because again, it's a horizontal line, but I didn't have any sort of a vertical shift. I stretched it vertically, but it's not like I moved all the values up or down some value, is what we're talking about in this case. And this center line idea is going to be important when we get to our next section, when we're going to be given a graph and we have to create the equation from it. That center line is going to give us all kinds of good information. So again, that's just kind of an average. If you take your max and min and find the average, that's how you're going to find your center line on any of these. But we'll keep referencing all these things as we're working down. But keep the questions coming too. Okay, next one, we get some interesting business work in here. So I look and I notice right away a couple of things. I notice I'm going to be going, I'll just kind of make myself some notes here to the side. This 1 is an up or a down shift, so I'm going to be shifting up 1, and I'm also going to be shifting right pi over 4, just to get myself a little of an idea of what's going on. Now, this is just me. I still would begin my graph when I was making my axes. I still would be putting where my normal bases would be, and here's why. Sometimes by seeing those, and you're like, okay, all of the values that I'm going to be putting in are going to shift pi over 4 to the right. So I'm like, okay, so if I'm at 0, I'm going to be at pi over 4, okay. If I'm here and I shift right pi over 4, remember, it's like 1/2 plus 1/4. I kind of forget the pi's there for a minute. So 1/2 plus 1/4 is 3/4, or 3 pi over 4. If I'm at 1 and add 1/4, that's 1 1/4, or 5/4, and some of you might hopefully see the pattern by now. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Again, the base graph, even those angle values are so critical, because now, especially with me, since I used a different color, now I know this is where my 5 points are going to go. So I'm like, okay, what else do I need to figure out here? Well, all my values are going to go up 1. My y values are going to go up 1. So on a typical sine graph, all of these y values at my new angle points are going to go up 1. So instead of pi over 4, which is my new first point, being at 0, it's going to be at 1. 3 pi over 4, which is now my second point, instead of being at 1, it's going to be at 2. At my third point, instead of being at 0, we're back up to 1. At my fourth point, instead of being at -1, we add 1, we're back to 0. And at 2 pi, or now 9 pi over 4, because that's my new fifth point, instead of being at 0, I'm back up 1. And I'm back to where I need to be. But again, everything bases off those angles and these initial values. Once I have the picture, then it's much easier to come up with all of the information. Because now I can say, okay, well, let's see. My max is up here at 2. My min's down here at 0. So my center line that basically splits, not spits, my graph in half is at y equals 1 because I shifted up 1. There'll always be a direct correlation between my center line moving from 0 and there being a vertical shift. If it doesn't shift up or down, this is always at 0. If there's an up or down shift, this is going to go with. Just something to keep in mind. An amplitude, I don't have a coefficient in front of my sign here this time, so that'd just be 1. I don't want to put none, because that would be kind of difficult. That'd be 0. We wouldn't even have a graph. My period, I didn't have any value in front of my x, or if it's theta sometime. So the period didn't change, it just shifted, because from pi over 4 to 9 pi over 4 is still a distance of 2 pi. But my phase shift, like we wrote up before, was right pi over 4. So that's how we tackled it. So like I said, it's much easier to get this once I draw it, but I got to take this in pieces. Little pieces, but pieces nonetheless. Issues on 2, because the next one at least gets a lot easier. We go from easy to tough to back to easy. At least I hope it's easy. Okay, this time I only have one thing changing. I have a b value of 3, which affects my period. Because whenever we have a b value in front of x, we're going to divide by my b. So 2 pi over 3 is my new period. Now, this gets a little more interesting again. Because when you divide by 3, that's the same as taking my angle measures and multiplying all of them by a third. So this time when I get started, it's not going to be these values that are changing, okay? Not my y's. It's going to be these. So each of these, I'm going to multiply by 1/3, and that's going to be my new points. Let's see, how am I going to get all this to fit? There we go. Okay. So if I'm at 0, and I multiply it by a third, okay, that's still going to be at 0. So my first one's not going to move. Pi over 2 times 1/3. Basically, you're just multiplying the denominator by 3. So I've got pi over 6. 1/3 times pi is pi over 3. Ooh, 3 pi over 2 times 1/3. So this will become a 6, because 3 times 2 is 6. 3 over 6 is a half, so pi over 2. And then 2 pi times 1/3 is 2 pi over 3, which I was hoping it would be, because that's the end of my period. And I have my 5 values that I'm going to be graphing. So I feel good about this. And now it actually is easy after this, because now I have, all I got to do is take my y values of my cosine and pop them into my points, just in the order they're in. So at 0, we're at 1. At my first point afterwards, okay, my the artist formerly known as pi over 2 is now at 0. We drop down to -1, back up to 0, and then back up to 1. The only thing that happened was that I kind of squished my graph a little bit into a shorter period. Everything else works the same. But again, I'll keep saying it and saying it and saying it. It all comes back to knowledge of your base graphs. So did I shift up or down at all? No. Which means what? Which means my center line didn't shift up or down at all. So it's still at 0. Did I have an A value? Did I have a value in front of cosine? Nope. Still going to be 1 for my amplitude. Did I do any up, down, left, or right shifting? Nope. So that one ends up being about as straightforward as it can be, which is good because it's nice we get one that's easy because, well, the next one, we're going to get to try everything out. Whew, here we go. All right. First thing I always want to battle whenever I'm doing these is period changes. Period changes make the biggest impact on my graph, so I always want to locate that first. So I'm like, okay, ooh, I have a value right here this time. All right. So my B value is pi, which means I'll take my 2 pi and divide it by pi, which means my new period is going to be 2. We'll talk about that in just a second. Let's go ahead and we'll get the other values in here. I have an A value this time, okay, right here directly in front of my sign. So my A value is 3, which means my amplitude would be 3. I notice there's a +1, which means there's going to be a shift upward, which also means my center line is going to shift 1 upward. And then my phase shift, whatever's inside the parentheses, means I'm going to be shifting left 2. So I got all sorts of fun stuff going on here. But again, this is always the priority. So you're like, okay, so I'm taking my period and dividing by pi. So does that mean I'm just taking all the angle measures and basically just dumping the pi from each of them? Right. 0, 1/2, 1, 3 halves, 1.5, 2. There's my period, okay? So when I'm doing these, I have 1/2 and 1 and 3 halves and 2, but, ooh, why do you have to say but? My phase shift is going to be left 2, so let's think about that. Normally I start at 0. Now I'm going to start at -2. Uh-oh. So if I start at -2, does that mean I need to count by halves all the way back? -3 halves, -1. We're not going to be quite as spread out the way we would like with our tick marks. I guess I should have thought of that at the start. But that's okay. By marking my tick marks like this, at least you're going to be able to show me where all your values are at. So you're like, okay, Harty, this is becoming a mess. So how am I supposed to figure all this stuff out? So I look and I go, well, I'm noticing a few more things here. I'm seeing we're going to be multiplying by 3 and going up 1. So I want to go to at least 4 with these. And I'll be honest, on a problem like this with so much going on, I would probably start doing side work because I just would be, my head would start spinning at this point. So maybe I'd start doing something a little bit like this. I go, okay, I need to get these angle measures figured out. I know they normally start at 0, pi over 2, pi, 3 pi over 2, 2 pi. Or in this case, 0, 1/2, 1, 1.5, 2. But they're all going to shift left 2. So normally if I start at 0, my first points can end up being at -2. Which is weird because we're seeing pi over here. So then my 1/2 left 2 would be the -3 halves, or the -1.5. And my 1, if I go left 2, is at -1, and then -1/2, And we're actually going to end up starting back at 0. And then if I wanted to keep going, I'll see this pattern. But those are my 5 points that cover me for my period change and my phase shift. These two, okay, have to do with my angle measure. The other two, the amplitude and the vertical shift, these two guys both have to do with my y value. So when I'm trying to figure out, okay, so what are these y values going to be at these points? Well, I've got to think about it because it says sine. So my sine normally for my first point starts at 0. So I say, okay, 0 times 3 is still 0. Up 1 is going to put me at 1. So I'll do the amplitude, then I'll do my vertical shift. Normally for my second value at sine, it's at 1. 1 times 3 is 3. Up 1 more is 4. Now here's the part where it gets easier though. Remember how in my first one it usually starts at 0, so it's like 0, 1, 0. Any place that there normally was going to be a 0 before, except this was 0. 0 times 3 is still 0. Plus 1 is 1. And normally when I get to that fourth value, it's at -1. Times 3 is -3. Up 1 puts me at -2. And at this point, I can actually graph these. I can go to -2, 1. I'll try to make these as big and dark as I can, since I have a line right in the way. -3 halves, we're up to 4. -1, back to 1. -1/2, we're down to -2. And at 0, we're back up to 1. So we go into curve mode, and I can see where that center line is now. Right here at 1, just like it was supposed to be. So again, base graphs, base graphs, base graphs. If you understand those, the rest of it, when you get into something like this, so just remember, both the things that start with P, period and phase shift, have to do with my angle. Amplitude and vertical shifts both have to do with my y values. It's one of those things, again, you keep playing with. If some of you hadn't maybe done that extra credit with the graphing in that packet, maybe you do that now. It's a good practice. Or you go back and see if you can do these later, and then look at the key or watch the video, see how it goes. Whew. Now a few things go a little faster. Reference angles. Remember, ladies and gentlemen, those are how can I most quickly get back to the x-axis. In other words, where is the fastest or closest way I can get back to 0 or 180 or 360, otherwise known as 0, pi, or 2 pi. Fastest way I can get back. Always positive. Even if your angle measure is negative, your reference angle won't be. And hopefully this is where the unit circle starts paying a little bit of advantage too. 300, closest to x-axis, 360. 60 away, that's all I need. -120, that also goes for these as negatives. What's the closest to 120? 180 is. They're 60 away. Even though it's a negative angle, doesn't mean the reference angle's negative. 2 pi over 3. Oh, geez, Harty, you're throwing fractions at us. Okay, closest one is pi, which is 3 pi over 3. Because again, if you divide a number by itself, it's a whole number. I'm pi over 3 away. Now I'm going to warn you, because I know somebody's going to do this. Somebody's going to look at that and say, I'm going to turn this into degrees, because that's easier to think about. 2 times 180 is 360, divided by 3 is 120 degrees. That's okay. You can even say, okay, 180 minus 120 is 60. That's even okay. But you better turn that 60 degrees back into radians, or you're going to see the infamous radians comment on there, and I'm going to mark it wrong. So again, if it starts in radians, it's got to end in radians. No exceptions, now that we've had like 2 quizzes already that has talked about it. Same thing here. Closest one. You're like, I'm not sure what the closest one is. I'm going to do the degree thing. Okay, that's okay. Just be careful. 5 times 180 is 900. Divided by 4 means this is negative 225. Looks like 45 away to me, but it's not 45. Pi over 4 is 45. Because we know how to speak the language of trig love and get back in this way. You don't speak radian, trig's not going to serve you well at all. All right. Convert each degree measure into radians and radians into degrees. No problem. Now, if you know your unit circle, you might know this off the top of your head. But if not, not going to get you in trouble yet. Don't leave it this way, though. Reduce it, reduce it, reduce it. And same thing with the other way around. If you remember, awesome. If you don't remember, work it out. And play that way. This next part is the part that drives people nuts. Find the exact value. Again, I do not, I'm writing it on here. We are not at a point yet, again, still that you know what the square root of 2 over 2 is off the top of your head probably, or that the square root of 3 over 2 is 0.8660, something like that. When you get to a point like an actual trig or pre-calc or something where you know those off the top of your head, okay, then go to a decimal. For now, no, not so much. So, what am I supposed to do then? I'm not sure what I'm supposed to do at all. Use reference angles, because again, this is going to help push some of you towards that unit circle. What do you mean? Okay, negative 135, reference angle, 45 degrees. 45 degrees I know are square root of 2 over 2 because I'm working on my unit circle coincidingly with this. But I also have to remember what quadrant we're in to know if it's positive or negative. Because just because it's a negative angle doesn't mean it's a negative value. So here I'm like, okay, negative 135. I'm over here. Is this sine country? I don't think so. It's tangent country. Knock it out. Cosecant of 150. 30 degree reference angle. You're like, oh my gosh, Harty, you're killing me. You're going to throw these in? Oh yeah. Cosecant, let's see. That goes with, oh God, sine. Okay. Now, not only do I have to think about that, because if I thought about it as sine, and I thought about it as sine of 30, I'd say, okay, that's 1/2. But here's my problem. Cosecant, right, makes it the inverse, which is 2, and 150, we're in sine land, it's positive. Gonna make you think about this stuff. And now I'm going in crazy directions. I'm just going to keep going down. Forget it. That's fine. Sine of negative 330, 30 degree reference angle. Could you draw a picture if you wanted to? You could if you don't have your unit circle done yet. Remember, one of your options, you could draw yourself a unit circle like we used to do. Make yourself a little 30, 60, 90 triangle with the sides that we know so well. And then say sine is opposite over hypotenuse and negative 330 is in the first quadrant. That's an option. If you need to draw a picture and use special right triangles, I say do it. But if you know your unit circle, use it. Negative pi over 3. 180 over 3, it's negative 60. My reference angle is 30. You're like, now what am I supposed to do here, Harty? You can't use your unit circle on this because it's only sine and cosine. Well, let's see. I have a couple of answers for you on that. You still could draw a picture. So that's negative 60, okay. So if that's negative 60, there's my 60, there's my 30. I'm going to prove to you in a minute I can still use my unit circle if I want to. Now if I wanted to, I could say, okay, tangent is opposite over adjacent. Square root of 3. Down here, this is cosine land, this is tangent, that doesn't work. Remember, when you're doing these, that tangent, if you remember back from a little while ago, did I just flip them around? I just did, didn't I? Cosine divided by sine, sine divided by cosine. Oh my gosh, why am I drawing a blank when I need to use this to prove my point? It's sine over cosine. I'm sitting here going, I know this isn't right. I'm just staring at it and I know it's not right. That's better. So I also could use my unit circle things and use those values. But again, a lot of times on tangent, you're going to think faster to just go ahead and draw this. So I'm going to leave it as such. But those are the types of ideas that we're looking at there. And I'm going to skip around a little because while you're still here, I'm going to show you these. And I'll finish off the other ones and get them online so you can kind of see what we're up against here. All right, I'm going to skip down to 21 and 22. State what quadrant you are in if tangent is positive and cosine is negative. Where is tangent positive and cosine wouldn't be? Three. See, some of you wish I'd have been that straightforward with language on the last quiz. I won't guarantee I'll be straight with language again tomorrow. I might go back to my greater than, less than thing. So, but now you all know what I'm up to, maybe. Find a value of x where the following is true. Sine x equals 1/2. Is there more than one solution? Uh-oh. Sine is 1/2. Well, I know sine is 1/2 at 30 degrees, and it's positive. Would sine equal 1/2 at another degree measure? Maybe a degree measure in quadrant 2 that has the same reference angle. Okay. Because if I found it in quadrant 3 or quadrant 4 to be negative, it wouldn't work out well for me. So that's one thing that I'd have to watch out for, that I'd have to look for. And then finally, and this is just labeling, this is the simple stuff. Using radians, find the amplitude and period of each function. Okay, my amplitude is just the absolute value of my a value. So, I mean, that's not going to be bad on any of these. But the period, remember, always starts as 2 pi, and we're going to divide by whatever my b value is. So my period, 2 pi over 4, otherwise known as pi over 2. Or 2 pi divided by 2 is pi. Or if you divide it and it doesn't simplify, that's okay. Like I said, I will have the rest of the answers online. Or if you decide you want to pop in tomorrow morning or later in the day or something like that, I'll have the answers and those things available. But this will be up. The blank of this will be up. Look the stuff over. Again, use the different methods. Find one that works for you, especially on the exact values. Quiz when you walk in tomorrow that'll look very, very similar to this.